have two bodies, body A and body B, or car A and car B. They are moving in rectilinear path along a straight line, and this is moving this way with the speed of 10 meter per second, and its speed is 20 meter per second this way. We are asked when and where these bodies they are going to meet each other. Obviously at t is equal to 0, this is the scenario, and in all such questions where one body is coming this way, one body is coming this way, when and where they are going to meet, or the questions like one car is moving in this direction, the other car is chasing this other car with a greater speed or velocity or acceleration, when and where they are going to meet, or the questions like from a high tower a body is dropped and from here a bullet is projected up, when and where they are going to meet. In all such kind of questions, our first line is generally reserved, and we say let they meet after time t. So we say let they meet after time t. Obviously at t is equal to 0, this is a scenario, this is having a greater speed, so had the two speeds been equal, they would have met in the middle of this path, that is at a distance of 45 meters from either of these two positions. But now its speed is higher as compared to this, so they will not be meeting over here, they'll be meeting somewhere over here. But they are going to meet at one instant. We are not going to say that this is going to meet this body earlier and this is going to meet this body later. So when we say that is let them meet after time t, it means meeting is this and this, we are taking as point masses, so we are not bothered about their dimensions. So this is the distance which is traveled by A, and this is the distance which is traveled by B. So we say the distance traveled by A plus the distance traveled by B, that has to be equal to 90 meters only. Also distance is equal to speed into time. So this distance traveled by A is equal to speed into time, that is 10 into t, speed is 10 meters per second and time we have taken as t only. What is the distance traveled by B? It is 20 into t is equal to 90. So t comes out to be 90 upon 20 plus 10, 30. So this comes out to be 3 seconds. So these bodies, they'll be meeting each other at t is equal to 3 seconds, and in 3 seconds obviously this would have traveled, distance is equal to speed into time, that is speed is 10 into 3, that is 30 meter. So this would have traveled 30 meter, and this would have traveled 20 into 3, that is 60 meter. So we have found both the things, that is when and where they are going to meet. Let's take the second case. We are on a straight path. This car is going this way with the initial velocity, let's say 5 meters per second, and its acceleration is 1 meter per second square. This is car A, and at a distance of let's say 20 meters there is car B, which has initial velocity is equal to 0 and acceleration is 2 meters per second square, and we are asked when and where B is going to catch up with car A. Obviously the speed of this is higher, initial speed is higher as compared to this, but the acceleration of car B is higher as compared to this. So gradually what will happen is, initially it may be, that is the distance between the two initially may be increasing, but gradually its velocity will become more than the velocity of this. As a result, the distance between the two will be shortening, it will be getting reduced, and at one time this is going to catch up with car A. Right now we are not bothered about the calculation, we are bothered about the concept. So let's say once again this catches up with this at time t. So we say let them meet after time t. Let they meet after time t. So in time t, so this is the time t is equal to 0 scenario. We have started our stopwatch, and at time is equal to t seconds, let's say both of them they meet. Obviously then their coordinates are going to be same. So this car has gone from here to here. This we represent by distance traveled by B, and from here to here is the distance traveled by A. So obviously in time t it has gone from here to here, and B car, it has to travel this distance also, and also it has to cover this 20 meter lag also. So looking at this, SB is going to be equal to, so SB is going to be equal to, so the distance traveled by this car B should be equal to distance traveled by A plus 20 meter. Rest is we can use directly S is equal to ut plus half a t square or so. If the body is moving the constant speed, Then if we say S is equal to ut plus half at square, if acceleration is 0, that is the body is moving in the constant speed or velocity, then A becomes equal to 0 and the distance assumes the formula distance is equal to speed in time. Otherwise, if there is the acceleration, we can use S is equal to ut plus half at square. There may be acceleration, there may be retardation also, any other cases. So we use S is equal to ut plus half at square. So SB, if we use it for this, that is SB is equal to ut, that is 5t plus half. A is 1 into t square. T is the time it takes to go from here to here, and this body takes time t to go from here to here. For SA, ut plus half at square, u is 0 plus half 2 into t square. Now we put these two in this. So SB is 5t plus half into t square is equal to half into 2t square. T is not equal to 0, so t comes out to be 10 seconds. So it means in 10 seconds this body is going to catch up with this body. Now let's take the third case, where from a high tower, we can take any height of the tower. Let's say we take it as 100 meter, and from here our body is dropped, that is u is equal to 0, and from here our body is thrown up, it is projected up with the velocity of 30 meter per second. We are asked when and where they are going to meet. We are asked that. So once again we say let them meet after time t. Let them meet after time t. Let them meet at time t or after time t. So in time t, this body A, if we say, and this is we body say B, so this is the distance traveled by A and this is the distance traveled by B. So if we say the distance traveled by A plus distance traveled by B, they should be equal to what? That should be equal to 100 meter only. What is the distance traveled by A? S is equal to ut plus half at square. It has been dropped. So u is 0, half A. In the downward direction it is going and it is velocity is increasing, so acceleration is positive. A is equal to g. Let's take g as 10 meter per second square only. Half A t square. This is SA plus SB. What is SB? S is equal to ut plus half at square. U is what? 30 meter. ut plus half. It is going up, its speed is reducing, so obviously it is retarding. Retarding is negative, minus 10 into t square, so this is equal to 100. We can solve this equation to get the value of time. If we intend to use sign convention, over there one point it has to be taken care of. Like for SA, if we are using sign convention, that is we are taking the vectors in the upward direction and vectors in the downward direction is negative, then SA is going to be u is 0 plus half. We are taking the acceleration in the downward direction, and in the downward direction it is negative, so it is going to be minus 10 into t square. SB is going to be displacement. Now it is distance, now it is displacement, this is also displacement. They are not the distances, whereas over here we are talking about the distances only. But if you are talking over here, now we have used the sign convention, so this is displacement, this is also displacement. SB is equal to ut plus half at square. U is in the upward direction, that is 30 into t plus half. Acceleration is g in the downward direction. In the downward direction we take it as negative, so minus 10 into t square. Now we have SA and SB. Now we cannot say SA plus SB is equal to 100. We cannot say that. Reason being, this SA is going to be negative. It is a displacement. So this is negative and this is positive. We cannot say, suppose from here to here is 40 meter, this distance is 40 meter, then certainly this distance is 60 meter. When we say SA plus SB is equal to 100 meter, it is something like saying that this is negative, this will come out to be negative. We are saying something like minus 40 plus 60 is equal to 100, which is not correct. So if we have to use SA plus SB is equal to 100, first we have to convert both of them, be it positive, be it negative. So let's take their magnitude only. That is, once again we shall be doing it, the magnitude, this should be positive and this should also be positive. It can't be negative. So both of them should be positive. So what we do is, SA if we have to take it as, so it is going to be half into 10 into t square plus this thing SB, that is 30t plus half minus 10t square, this going to equal to 100. Then we can solve it and we can get the value of time t. So this is the point you have to take care of, that is when you say SA plus SB is equal to 100, over there take only the magnitudes, and if you are taking the direction into consideration, you have to see that is both the vectors, they are aligned in one direction only.